Okay, so before we move on to the ideal gas equation, we have a short lecture here on dryness fraction and stuff. It's dryness fraction. It is acting up for some reason. Okay, so yeah, as I was saying, we're going to talk about dryness fraction in this lecture, right? So, what is the dryness fraction? We know that in our graph, our TV graph that we have been discussing so far, a substance can lie anywhere on this line, right? On this line. Over here, we know that it is a superheated vapor. This is the superheated region. And over here, we know that it is the subcooled region. However, this entire region is a saturated mixture. Saturated mixture. That means our vapor and liquid exist simultaneously, and this point was Vf and this point was Vg. That is, when the substance is anywhere over here, a situation in our diagram, recall from the previous lecture, looks something like this. So now our problem is, how do we determine how much of this is vapor and how much of this is liquid? How do we know? So for that purpose, we define something called the dryness fraction, and this is a very useful quantity, small x. It is denoted by small x. Some people do write it like this also, but personally I find small x to be more convenient. So dryness fraction is defined as mass of vapor by total mass of mixture. So this mass, the mass occupied by the vapor upon the total mass of the mixture, will give us the dryness fraction. So clearly we can see that if we multiply it by 100, this will give us some percentage, right? So from this, what we can interpret is that dryness fraction is the percentage of vapor in mixture by mass, because we're dividing mass in both numerator and denominator, and if we multiply it by 100, we get percentage mass, right? So, and another thing to note is that as we go along this line, x increases. Why does that happen? See, because we are going from Vf to Vg. That means we are going from the subcooled region to the superheated region. And we know that from this point to this point, more and more and vapor condenses, right? More and more liquid gets converted into vapor. So your mass of vapor increases, but as mass is conserved inside the whole container, this is constant. Therefore, your x has no choice but to increase, not decrease, increase. So, yeah. And one more thing, obviously, since it is percentage, x is always between 0 and 1. Okay, now this is something that's a bit tricky. At saturated liquid point, as such, x is not defined. However, we often say that x is 0. Similarly, at saturated vapor point, I hope you remember what these points are. This is the saturated liquid point, and this is the saturated vapor point where only vapor and liquid exist, respectively. Similarly, at saturated vapor point, X is not defined, but we say it is 1. Because intuitively, at saturated vapor point, we know that everything is in vapor. So intuitively, we can say that mass percent of vapor is 100%. So X can be said to be 1. Now, a very good use of this dryness fraction will come when we want to determine the specific volume of the mixture, or the specific internal energy, or the specific enthalpy, and so on and so forth. So how will that happen? If we saw we if we see previously, we saw that X equals to m vapor by m total, right? We can also write it to be V minus Vf upon Vg minus Vf. So now if we manipulate this a bit, we can see that V of the mixture equals to Vf plus XVFG. This is the formula that you need to remember. Similarly, we can also say U mix equals to UF plus XUFG, or H mix equals to HF plus XHFG. Basically, to determine any specific property of a substance that is in this region, you can substitute the quantities here and get that property of the mixture, provided that you know the dryness fraction as well. So that is why dryness fraction is so important, because it helps us determine the specific property of mixture. So we're able to find out the volume, specific entropy, enthalpy, internal energy. So if we find out the specific volume, we're going to find out what point on this line is our mixture. So for example, we can say that this is the V mix. And to find this out, we know the Vf and the Vg from the tables. And X we will be able to find out some other way in the question. And then we'll be able to apply V mix equals to Vf plus XVFG to find out what this point actually is. However, we will see all of this when we are solving questions. So all you need to understand right now is this formula. Not even the derivation, just remember this formula. You don't need to understand where it came from. And you need to understand what dryness fraction as a concept represents. So yeah, after this we're gonna look at the ideal gas equation that I have been putting off for so long. And yeah, let's go.